I'm 1E. I'm going to explain about interval estimation today. We need to understand confidence level for interval estimation. I said there are two types of estimation. One is point estimation, and the other one is interval estimation. Point estimation is estimate by a single value, one value, okay? Interval estimation is a range interval where parameter lies, something like that. Anyway, I made a mistake on pointer estimation here. Okay, the length of time it takes to reach the summit mountain. Okay, it will take 35 minutes. That is point estimation. About means some range, so you ignore about. It will take 35 minutes, just single value, one value. Okay? Okay, let's go now. Here, interval estimation, confidence interval estimation. Point estimation involves simply estimating a parameter as a single value, so we can just say the unknown value is that estimated value, a single value, one value. However, interval estimation requires a bit more explanation, a little complicated. Interval estimation refers to determining the range within which an unknown value, parameter, right? Unknown value is a parameter of a population lies. To perform interval estimation, concept of confidence level, degree of confidence is necessary. What is confidence level then? For example, it might feel somewhat unsatisfactory to pinpoint the time to reach the summit as 35 minutes based on sample, okay? Reports of several people. Instead, it is more persuasive to estimate the time as following within a range of 30 to 40 minutes, because the estimation based on sample. However, the problem arises in asserting that the value of definitely exists within the 30 to 40 minute interval, right? The definitely exists that interval? No way. Then what kind of thing we need? That is confidence level. Therefore, we need to understand the concept of confidence level, which refers to degree of belief that the unknown value parameter lies within that interval. For instance, for example, if the estimated time to reach the summit is given as interval 15 minutes to 55 minutes. Wow, 15 minutes to 55 minutes. If somebody said like this, then would that be reasonable? No way. Why? The interval, width of interval is too big, 40-minute interval. So everybody knows it will take between 15 minutes to 55 minutes. So the width of the interval is too broad to consider it an adequate estimate, since that anyone would think the parameter time to the top, okay, unknown value falls within that range. So it is useless. If you estimate the time to reach the summit as 30 minutes to 40 minutes, wouldn't it be a more appropriate or reasonable interval? Yes. We used to say it will take 30 to 40 minutes, something like that. Nobody say 33 minutes to 37 minutes. It is hard to say. I mean, the expression. Don't we often say in casual conversation, it will take about 30 to 40 minutes for another matter, okay? Let's see this a little more. For example, the interval 15 minutes to 55 minutes could be thought as having a confidence level. What? Everybody, take that interval, I mean, believe that interval cover the unknown value, 99.9%, because it is too big. While the interval 30 minutes to 40 minutes might be considered to have a confidence level of around 90%. Okay? around 90%. This one. In other words, a higher confidence level results in a wider confidence interval, while a lower confidence level, like this 90, results in narrower interval. Okay? It is natural. Generally, a suitable confidence level is set at 95% when estimating confidence interval. Generally, we use 95% confidence level. Let's estimate the confidence interval for the population mean mu at a confidence level of 1 minus alpha 100%. Alpha equal to 1.05, then it is 95%, right? Okay, let's focus on mu. Then you may understand for other parameters. Once you understand this, it will be easier to grasp the estimation of other parameters as well. For the estimation of the confidence interval for population mean mu, X bar should be used. Why? X bar is the best estimator for mu. This is because X bar is the best estimator for mu. Therefore, let's use the distribution of X bar. X bar has from central limit theorem. X bar has follows normal distribution with mean mu variance sigma square over n. When X bar is standardized, G, X bar minus mu divided by sigma over square root n. It has normal distribution and what? Mean 0, variance 1. And from this, we can obtain the confidence interval for mu with a confidence level of 1 minus alpha 100%, like this. 1 minus alpha dropped at center of this normal distribution. Then the tail part is alpha over 2, okay, equally. Then we can get G value from the standard normal distribution table. When alpha equal to 0.05, it is a very famous value. So then this area 0.025, 0.025. Then the value of G, small g, 0.05, sorry, 0.025. 0.025 is 1.96. I mean, 1.96 is very famous value for normal distribution because we used to use confidence level as 1 minus alpha. 1 minus alpha is just in center. Okay? Okay, let me continue tomorrow, next time. Okay? Thank you. Bye.